The given problem says that a metal of work function 3 electron volt is illuminated by light of wavelength 3000 angstrom. Calculate the threshold frequency, the maximum energy of the photoelectrons, and the stopping potential of the electrons. So first of all, we will calculate the threshold frequency. So we know that threshold frequency is dependent on work function as follows. So work function phi is equals to h nu naught. So we can find the threshold frequency nu naught as phi over h. So work function phi here is not in joules. Once again repeating, it should be in standard units, which is joules. So let's convert this 3 electron volt into joules by multiplying with 1.6 into 10 raised to minus 19 and dividing it with Planck's constant, which is 6.626 into 10 raised to minus 34. And when you divide it, we get the threshold frequency as 0.72 into 10 to the power 15 hertz. Now let's calculate the second part, which says the maximum energy of the photoelectrons. To calculate the maximum energy of the photoelectrons, first we use Einstein's photoelectric equation. So let me write here B, and let's write here Einstein's photoelectric equation, which says that the maximum energy of the photoelectrons must be equals to the energy given by the photons minus the work function phi naught. So we know that phi naught, the work function, is nothing but h nu minus h nu naught, where nu naught is the threshold frequency. If I take Planck's constant h common, we left with nu minus nu naught. As per the problem, we are given with the threshold frequency. Threshold frequency, we already figured it out in part A. Let's calculate our nu, the frequency of the photons. So we are given with the wavelength of the photons, which is 3000 angstrom. So nu must be equal to c by lambda, and c is nothing but speed of light. So 3 into 10 to the power 8 divided by 3000 angstrom. So to convert this angstrom into meters, since we are using speed of light in standard units, so we have to convert this into standard units. So 3000 angstrom will be 3000 into 10 to the power minus 10, and this will give us the frequency of the photons which are imparted on the metal. So that gives us 1 into 10 to the power 15 hertz. After substituting this frequency, let's see how much we get as the energy of the electrons, photoelectrons. So energy of the photoelectrons can be calculated as 6.6 into 10 raised to minus 34. That's our h into nu minus the threshold frequency. Nu is nothing but 1 into 10 to the power 15 minus the threshold frequency. We got it as 0.72 into 10 raised to 15. So 1 minus 0.72 into 10 raised to 15. Now let's simplify this. We will get it as 1.86 into 10 raised to minus 19 joules. Be very careful, the answer is here in joules. So we can also convert this answer into electron volt by simply dividing it with 1.6 into 10 raised to minus 19. So the energy E of the electrons in EV, electron volts, will be equals to 1.86 into 10 raised to minus 19 whole divided by 1.6 into 10 raised to minus 19, and that gives us as 1.16 electron volt. So let's do the third part. The third part says calculate the stopping potential. To calculate the stopping potential, let's recall our equation of stopping potential, EV naught, which is equals to the maximum kinetic energy or the maximum energy given to the photoelectrons. So stopping potential V naught is nothing but E divided by E. So E here must be in joules, which is 1.86 into 10 raised to minus 19, and divided by the charge on a single electron, that is 1.6 into 10 raised to minus 19. We get here 1.16 volts. This is our stopping potential, which is given across the anode to stop the electrons which are coming from the metal plate.